Section P.8. I gotta convince you that to solve word problems, you must use words, and we're gonna do that. The process for solving word problems. Read the problem carefully several times until you can state in your own words what is given and what the problem's looking for. That just takes a pause. You read some, and math students don't like to pause. They like to keep going as if they would die if they stopped. Just take a pause after you read the problem and go, what's this problem about? What do I know? What am I looking for? Let X be one of the things that you don't know. It's usually the thing you're looking for, but not always. Sometimes you have to find one quantity before you can actually find the thing you're looking for. But let X be one of the unknown quantities. Step 2, if necessary, if you have other unknown quantities, then write those expressions in terms of X. If Sue has $7 more than Bob, let Bob's money be X, and then Sue's money is X plus 7. Once you get all the unknown quantities labeled, all the known quantities and the unknown quantities labeled, write a sentence using those words that I encourage you to write down until you've practiced this a lot. But once you practice it a lot, you don't have to write the words down anymore. You don't have to write the sentence down anymore. But gosh darn it, you have to think the sentence. If you want to be good at word problems, you have to be able to think in sentences. Translate that sentence into an algebraic expression using the expressions you've divided. I'm stuttering again. Translate that sentence into an algebraic equation using the expressions you divide. Making the sentence is the hard part. Once you have the sentence, the equation is going to be easier. Step 4, solve the equation, answer the problem's question. X equals 12 is never, ever, ever the solution to a word problem. The person who asked you the question has no idea what X is. So you have to answer the question in the way that it would make sense to the person asking the question. You have to include appropriate units when necessary. Just because saying 12 doesn't tell me, how many grams of sugar in this. I need 12 grams, 12 gallons, 12 what? Check the solution in the original wording of the problem, not the equation that you got from the words. You don't need to just make sure you have found a solution to the equation. That might not be the solution to the actual problem. Why? You might have messed up before you got that. Yay, your answer checks in your equation, but if you have your equation set up wrong, then it's not the answer to the question. So if you want to, you can just write there because you may have made a mistake in setting up the equation. Formulas I would expect you to know. I wouldn't give you these on the test, and formulas that I would give you on the test. You should know by now the area and perimeter of a square, the area and perimeter of a rectangle, the area and circumference of a circle. The area of a triangle is just half of the area of a rectangle. So half of the base times the height. The only reason I would think that you should know the area of a trapezoid, do you even remember what a trapezoid is? Okay, your fingers, think Rolo candy.
Trapezoid, isn't that like the Pizza Hut sign? Like logo?
I can't picture the Pizza Hut sign all of a sudden. Does it look like that? Okay.
It's like a square ball.
Okay, no, I can't picture that. You have a short base and a long base, and then you have the height of the trapezoid. The area of the trapezoid is just the average of A and B. You average the short side and the long side, you add them and multiply by half, and then multiply by the height of the rectangle. So it's the average of the short side and the long side times the height. Volume of a cube, volume of a rectangular solid. What's the volume of a cube? It with side X. If one side's X, what's the volume of that cube?
X cubed.
Yeah, You've got length times width times height. That's the definition of volume. So x times x times x is x cubed. What about the volume of a rectangular solid? It's still, laugh at my rectangular solids. I won't laugh. Whatever you draw badly. In my case, that's everything. Oh, come on. Let's play like, I don't know, something went weird. Yeah, don't worry about that. But it's still the area of the end. The end is a square, or no, it's not necessarily a square, but it's a square with sides x and y. And then the thing is z units long, x times y times z, or I didn't use any variables here, would give you the volume of the solid. The volume of a right circular cylinder, I can do a little bit better. Again, it's just length times width times height, but if your end is a circle, then it's the area of that circle times the height. So pi r squared is the area of the circle times the height. Distance equals rate times time. Y'all know that. You should know interest equals principal times rate times time. You should know the Pythagorean theorem, which says what? Yep, and in terms of words instead of variables there, it's leg squared plus leg squared equals hypotenuse squared, or any right triangle. All right, those, if you think about it a minute, you should know all those. Maybe less obvious, volume of a sphere and volume of a cone. So I would give you those if I asked you a pop question about those. In addition to the 8 or 9 examples on this page, and we may not get them all done, look at the words in the book and look at the examples in the book and look at the way that our author, which I love this book. I think it's one of the most readable math books I've ever seen. But he emphasizes using words like, let's write the sentence first, and then let's just put our algebraic expressions in place of all the words in the sentence. Great way to do word problems. So in class examples, number 1, according to the U.S. Bureau of Labor Statistics, you will devote 37 years to sleeping and watching TV. The number of years sleeping will exceed the number of years watching TV by 19. Over your lifetime, how many years will you spend on each of these activities? What do you think? Okay, number 1, does that problem make sense? You understand? That's saying I'm gonna spend 37 years sleeping and watching TV, and I'm gonna spend more years sleeping than watching TV. I'm gonna spend 19 more years sleeping than watching TV. All right, so what would be a good choice for X here? Okay, any, mini, miny, mo. It doesn't matter if you let X be the years spent watching TV or you let X be the years you spent sleeping. Whatever you let X be, that's going to influence what you call the other one. So I like your idea. Let X be years spent watching TV. And I'm going to abbreviate some, or we're not going to get through this, probably not going to get through it anyway. But do you understand what I mean? All right. If that's the years spent watching TV, then what's the years spent sleeping? You're going to spend 19 more years sleeping than watching TV. Yeah, X plus 19. So I've labeled the thing that I don't know. I understand 37 is what I get when I add these together in my head. And again, I don't write these sentences down all the time, but I did when I was first learning to be good at word problems. So I was thinking years spent on TV plus years spent sleeping, the fastest way I can think to write it, is 37. And what can I put in place of this years spent watching TV? That's what we called X. What can I put in place of years spent sleeping? That's what we called X plus 19. And I know that the two of those together have to equal 37. Now, one thing I did to save us some time is we're not going to solve any of the equations today. I know y'all can solve equations. I'm just telling you I got X equals 9 for a solution to my equation. Is X equal 9 what I'm going to say to the person who asked the question? No. What am I going to say to the person who asked the question? That 9 is what? Years watching TV, because that's what I let X be. So that's 9 years watching TV, and how many years sleeping? 19 more than 9 is 28. Now, you didn't need my process for that. You could have figured it out just fine if I left you alone a minute. But if you practice this notion of using words and translating them into sentences on easy problems, then you can do the same thing when you get to harder problems. All right, so we're going to keep practicing that. In 2019, the average age of cars on US roads was 11.8 years. From 2008 to 2019, the average age increased by 0.15 years per year. So we're talking about the average age of cars on the road. This trend continues. How many years after 2019 will the average age of vehicles on the roads be 13 years, and in what year will that occur? I probably have to read it again and then close my eyes and say, they're telling me the average age in 2019. They're telling me how much that's been increasing each year. And then they're saying if it keeps on increasing at the same rate, how old will the average car be in 13 years? So what do you think X is? What are we looking for?
X to get to 13 years.
It says how many years. I think that's the first thing we have to find, is how many years after 2019 it will take them to be 13. Okay, so I know the age of the car. I'm wondering when that'll happen. So let X be, so what did you say? You said it well, I just forgot.
Years after 2019 to get
Okay,
13 years.
okay, let X be the years since 2019. Since we're looking for how many years after 2019 the cars will be 13 years old. What's the increase in age since 2019? What number in that problem has to do with the increase? Okay, 0.15, and is that saying it increased 0.15, or is it saying 0.15 per year? Per year. So how do I say 0.15 per year? Does that make sense? And another thing I do that really helps me is say, let's say I thought it was X plus 15. Then in 2019, would the increase be 0.15 plus X or 0.15 times X? That's 0.15 per year is 0.15 times the years. So here are the words I have. The years since 2019 and the increase in age since 2019. And I want to find out when the average age will be 13. Make me a sentence with these words and a 13 in it somewhere. Let's say the 11.8 and the 0.15. The average age in 2019 was 11.8, and then it was 15 years per year increase after that. How would you get the age of a car in, say, 2020? Average age of cars on the road in 2020.
Would be 620 plus.
Okay, that's how much it increased, 0.15, but that doesn't give me the age of the car in 2020. That just gives me how much it increased since 2019. The average age was. Yes, you got to take your initial age of the car at 2019 and then add the increase. So average, I'm just going to try to leave out some words here. Age at age in 2019 plus increase in age is 13. I'm looking for when the average age plus however much more it is increased is 13. So what symbol or symbols can I put in place of age in 2019? What was the average age of cars on the road in? That was the 11.8. So that plus the increase in age, what can I put in place of the increase in age? The 0.15x equals the 13. If I just walk up to you someday in Walmart and say 11.8 plus 0.15x equals 13, you can assume I've lost my mind because that doesn't make any sense. But if you have words attached to those numbers and those expressions, do the words make sense? Yeah. The age in 2019 plus how much it's increased since 2019, we're looking for when that will be 13. The answer comes out to be 8. If you come up to me and say x equals 8 after I've asked you this question, I'm going to know you lost your mind. Because I don't, 8 what? Hey, you said that beautifully. In 8 years, oh, but you said cost, didn't you?
No call.
Oh, okay. In 8 years, the average car will be 13 years old. I'm trying to write as quickly as I can. I'm just going to say 13 years. Have I answered everything that was asked of me?
No.
No, I just answered the first question. How many years after 2019 will the average age be 13? It also asked in what year will this occur? I don't get that
2027.
because that's what? Where'd you get it?
80 years plus 2019.
Yeah, 2019 plus 18. So I'm just gonna say, in 8 years, and then maybe a comma, 2027, the average car will be 13 years. All right. As the problems get more complex, it's more important that I use my words. So number 3, an electronic pass for a toll road costs $30. The toll is normally $5, but it's reduced by 30% for people who have bought the pass. So if you're only driving on this road once a year, it's not going to be worth paying $30 for the pass. You're just going to have to pay the whole $5 instead of the reduced rate. But if you drive that road every day, it probably will be worth it to you to buy the pass. That's all the thinking I have going on. I'm not just staring at the problem and waiting on God to whisper to me. I'm making sense of it with words. Determine the number of times the road must be used so that the total cost without the pass is the same as the total cost with the pass. You're trying to figure out that break-even point. When is it going to be, how many times do I have to go down this road in order for it to be worth buying that $30 pass just to get the little discount? All right, what do you think we should let X be? That's what we're looking for. This jumps out at me right here. We're looking for the number of times, so let X be number of times on road. All right. If you don't buy the pass, how much does X times the road cost? $5 each one. And then if you do that X times, what's your total cost? It's 5 every time you use it. The first time you use it, you're out $5. The second time you use it, you're out $10. Third time you use it, you're out 15. So the X time you use it, how much money have you spent?
So 5X.
Oh, I didn't hear you, Nathan. I keep telling y'all I'm deaf and you don't believe me. 5 times X is the total cost, not the cost each time, but the total cost of using that road X times if you have not bought the pass. Now, if you have bought the pass, how much are you paying each time? Just tell me how to calculate how much you're paying each time. You gotta tell me how. What'd you do? Focus, focus.
30% of
Ah,
3
Wait.
divided by 2, you get.
okay. I love that you were able to do that in your head. I started to say, it doesn't say 10%, but you said, take 10% and then, multiply it by 3. Is that what you said? You said.
No. Take 30% of 10 is 3. Divide that by 2.
Okay.
Yeah.
Okay. I
1.5 and then subtract that.
I love your number sense, the way that makes sense to you. You could, if you didn't have that way of figuring out, you could just multiply 30 cents times 0.5. That's your $1.50. Is $1.50 what you pay if you haven't bought the pass? Is that what you pay each time? 0.3 times 5 is $1.50. Is that what you paid? No, that's your, give me words. That's your amount of discount. So you're not paying the amount of discount, you're discounting the $5. And discount implies what operation in math? Subtraction. So 5 minus 30% of 5 is how much you're paying every time. And Kyle, you were able just to do that in your head, and that's awesome.
Can you just say, 0.7 times 5?
Yes, you could say if I am discounted by 30%, I'm still paying 70%. So you could just say 0.7 times 5 is the amount I'm paying. Lots of different ways to think about it, but you have to have words for why you're doing what you're doing. We've got this down to $3.50 per trip. So what is the expression for the total amount the person pays for X trips? This times X. Instead of paying $5 each time, they're paying $3.50 each time. So 3.5X is the total cost if you have bought the pass.
Well, wouldn't you include?
Yes, you would. You would have to. If you're going, how much money am I out? You don't get that discount for free. You have to pay the discounted amount every time you don't go down the road, but you also have to pay for the pass. So 3.5X plus 30 is the total amount the person is out. All right. Use total toll cost without the pass and total toll cost with the pass. Use those words to make me a sentence.
Something equal to each other.
You're looking for when the total cost without the pass is the same as total cost with the pass. So, when is total cost with the pass the same as total cost without pass? I reworded the whole problem into a sentence that makes sense to me using the variables and expressions I use to define the pieces, parts of the puzzle. And now you is the same as is where your equals goes. Total cost with the pass. What do I put in place of total cost with the pass? Yes, 3.5X plus 30. And what do I put in the place of total cost without the pass? 5X. That equation doesn't make any sense. The words make perfect sense. You solve that, you get X equals 20. What is that? What is that? What have we found? In order for what? Yeah, that's the break-even point. If you're going down this road 20 times, then it doesn't matter whether you buy the pass or not, it's the same either way. But if you go 19 times, what's your better option? Yeah, you won't get your monies back from the pass. But if you go 21 times, you will have saved money buying the pass. So the answer is, and just, I would make a complete sentence, but I know how much. I'm just going to say break even point is 20 times. I'll write it up officially in my report in a complete sentence. All right, number 4. The selling price of a calculator is $15. Do I understand what that means? That's how much it's going to cost me at Walmart, right? If the markup amount, if the markup which is the amount added to the dealer's cost of an item to arrive at the selling price. If the markup is 25% of the dealer's cost, I gave you some words there. That's called your percent markup. So do I understand what's going on? How is the Walmart price derived? You got TI making the calculators. They sell them to Walmart. Walmart upcharges them because they have to make a profit.
The base plus the base times their percentage mark.
Okay, so what are you letting X be?
The dealers.
That's the original, let me see. Yeah, that's TI, that's the person selling the calculator to Walmart. So let X be the dealer's cost. And then how do you get the amount of markup? How do you find the amount of markup? If the markup percent's 25%, how do you get the amount of markup?
X plus quarter of X.
Eventually, but I'm just talking about the amount of markup right now, and that's just the 0.25 times X. That's the amount of markup. And so how do you get the selling price? If the dealer is selling it for X and then it's marked up 25%, Augustus, what symbols can we use? What expression can we use for the selling price? And you said it already.
X plus 0.2.
Yeah, you gotta, what the dealer charges and then add 25% of X to that. And 1X plus 0.25X is just 1.25X is the selling price. So using the words dealer's cost, amount of markup, and selling price, give me a sentence that uses those words. How is selling price calculated? But I just want words instead of numbers and letters.
Dealer's cost is the base price plus 25%.
Well, what I have highlighted there, it is the dealer's cost plus not just the 25%, not the percent markup, but the amount of markup. The dealer's cost plus the amount of markup is the selling price. Exactly how business works. DI makes a calculator, sells it to Walmart for $10. Walmart marks that up 25% and then sells it for the selling price. So my equation, what am I going to put in place of dealer's cost? Dealer's cost is just X. What am I going to put in place of amount of markup? I already have it labeled. It's not just, oh, yes. 0.25X is the amount of markup. So X plus 0.25X equals what? Yeah, we're given the selling price. The selling price is 15, so I want to know when x plus 0.25x equals the 15, or when 1.25x equals 15. Just divide both sides by 1.25, you have x equals 12. What is that 12 that we have found? And it's dollars, with some units on there. Dealer's cost is $12. And when I said check it with your words, just think, okay, EI sells Walmart calculator for $12. How do I get how much the calculator is marked up? Well, the 25% of 12, that's a fourth of 12, $3. And so the selling price, if it was $12 and Walmart marks it up $3, what will the selling price be? So that checks. It checks with the words. All right, number 15. You invested $15,000 into stocks. Some was in a stock that realized a 15% gain, and the rest was in the stock that suffered a 7% loss. If you had an overall gain of $1,590, how much was invested in each stock? Any ideas what we should let X be? I know the total amount invested was 15,000, so I need to be more specific than that. It's the same amount in both. Not the same amount in both. I have two investments here. Let's see. Yeah, two stocks. We can call them any, meeny, miny, mo, A and B, if you want to, or anything you want to. The amount that I have in the first one is A, the amount I have in the second one is B, and they're not necessarily the same amount in both. So what do I let X be? It's the amount in, we could call it first stock or stock A. I'm gonna call it stock A since I've already written A and B up there. Let X be the amount in the first stock. And let's say it's the one that made you some money. All right. If stock A made you some money, then, and you invested 15,000 in all, what's the amount that lost you money? If you put X of the 15 in stock A, then how much does that leave you in stock B? Beautiful, 15,000, right? 15,000, you had $15,000 in all, you put X of it in one account, you have 15,000 minus X in the other account. Now, that's your principal in each stock. How do you get the amount of interest you gain? Principal times rate equals interest. So 0.15 times X would be the amount of interest you gain, and what would be the amount of interest you lost? Close, you're right about the 0.07, but I didn't have X dollars in the losing account. How much did I have in the losing account? 15,000 minus X. So here's how much money I made, 0.15 times however much I had in stock A. And the amount I lost was 0.07 times however much I had in stock B. And then,
So 0.07 times 15 minus X would give you how much you lost, but
yes,
but you would subtract how much you lost from your original amount,
mhm.
and then you add that to what you gained. So wouldn't it be 0.93 times 15 minus X?
Not the way I worded it. We're looking for the amount of interest lost. If I put, 7,000 in stock A, then that would leave me 8,000 in stock B. And 0.07 times 8,000 would be how much money I lost. Now, I wrote this sentence because I know we're running out of time. The interest gained minus the interest lost, no, sorry to say that's not a complete sentence, but I see it now. The overall gain is the interest gained minus the interest lost. So what's my overall gain? No, that's the 1,590. Is in the sentence is always where your equals goes. What's your interest gain? 0.15 times X minus what's your interest loss? Which I really didn't leave you enough room for. That equation doesn't make sense, but the words do. The solution to the equation is X equals 12,000, but what's the answer to the question?
12,000 was invested in.
Each one? Is that what you said? Well, 12,000 in each one would be a total of 24,000. Okay, 12,000, and this person didn't tell me what stock A was. I just made that up. So I want to answer it, $12,000. Ooh, I have some good words. In profitable stock, the one I gained money on, and how much in the unprofitable stock. Because they have to equal 15,000 in all. 3,000 in, I'm just gonna say losing because it's faster stock. I know we'll get at least one more done. We may get two. Just so you know, I'm gonna hang around and do the other problems. There's only 9 in all. I'm gonna hang around and do them just because I want to complete the video. But if you need to go, tiptoe right out at 9:55. It won't hurt my feelings at all. And by the time, sometime this afternoon, you could go home and watch the other examples if you need to. All right, number 6. Each side of a square is lengthened by 2 inches. The area of this new larger square is 36 inches. Find the length of the side of the original square. What do you think X is here?
Side length of the original square.
Makes sense. Let it be the most basic thing. Let X be side length of the original square. And what can we deduce from that? If each side of the square is lengthened by 2 inches. And what? Okay, perfect. Then X plus 2 would be the side length of the new square. X side length of the original, x plus 2 side length of the new square. And then the other sentence says the area of the larger square is 36 inches. So it gave me my sentence right there. The area of the large square is 36 inches. What can I put in place of area of the new larger square? Yeah, and you may be thinking, okay, here's my original square with all sides x, and here's my bigger square with all sides x plus 2. Well, the area of a square is side times side. So x plus 2 times x plus 2, or as Nathan said, x plus 2 squared is 36. There are two ways I could solve that equation. I could write x plus 2 times x plus 2, boil it out, have it equal to 36. If I did that, what would be my next step? If I had x squared plus 4x plus 4 equals 36. Next thing I have to do is subtract 36 from both sides to get it in standard form. What's faster than that?
Taking square root.
Square root method would be the fastest way. And when you took the square root of the right hand side, you'd have plus or minus 6. But does negative 6 make sense in terms of no? Yeah. Yeah. So you just say, so x plus 2 equals 6, x equals 4. And what is that for? Because that's what we let x be. Original side length was 4, and for what? For rhinoceri? 4. Oh, 4 inches. Darby, were you thinking something else there? Okay, you were saying something, I didn't know if it was different or you were agreeing. Okay, all right, last one we have time for. A rectangular piece of land whose length is 3 times its width has a diagonal distance of 92 yards. Can you picture that? It helps me to draw it because I can't picture anything. Here's my rectangular piece of land. The length is 3 times its width. What do you think I'll call x? Yeah, you tell me the length is 3 times the width. I'm going to call the width plain old x. Let x be the width of the yard. Then what algebraic expression would give me the length of the yard? It's 3 times the width. 3 times the width would be 3x. 3x is the length of yard. All right. What else do we know about this yard? Okay, I can put that in my picture. Here's the diagonal distance is 92 yards. And what do I know about rectangles and such? That, all right, that's Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Ah, that's my sentence, not my equation. Gosh darn it, I wrote that in the wrong place. What can we put in place of legs the first leg. Okay, doesn't matter which one. The first leg squared plus the second leg squared equals 92. I solved that. That's x squared plus 9x squared is 10x squared. Divide both sides by 10, take the square root, you get about 29. What is that 29? That's the width of the yard. Is that what we were looking for, the width of the yard? No.
We're looking for how many yards the person say about.
Okay, so how do I find that?
Be length plus width.
Oh,
Very, very, very close. But I don't want, which would be the longest route, going along the edges of this yard or cutting across the middle? So would it, yeah, cutting across the middle is always shorter than going around the edges of a rectangle. So it wouldn't be something minus 92, it'd be 92 minus something. You gotta have, wait,
that's the longest.
yeah, okay. I love to end a class by screwing up. If the width is about 29.1, and that would make the length about 27 or 87.3, is that 60 and 27, 87.3?
Could say 4 times 29.1.
Love how you think. Love, love, love how you think. Yeah, or you could just say there are 4 x's in all. So 4 times 29.1 is the distance if you walk along the edges. That's longer than cutting through the middle, so subtract 92 from that. And I have that written down somewhere. It's approximately 24.4 yards saved. All right, I have 2 more problems I'm going to do just to have on video. You can either hang around 10 minutes and we'll finish up, or you can go home and watch the video if you need to. What is it, Clayton?
I stay here until the point of your class.
Oh. Well, say you work on your homework.
That's what I was going to do. Stay there.
Okay, that's an excellent place to work. All right, last 2.
But
Use some words. Use some words. All right, number 8. An engine pulls a train 140 miles. Got an engine chugging down the railroad track for 140 miles. Then a second engine whose average velocity is 5 miles an hour than the faster or the first engine, it takes over and pulls the train 200 miles. The total time required for both engines is 9 hours. Find the average velocity of each engine. As I was saying, y'all know how bad I am at picturing things in my head. So I draw whatever I can, and I'm very limited in that way also. Here's what I'm thinking. Here's a train, my very best train. And let's assume he's going east for 140 miles. And want to call that train A? I call it something. Train A. but remember, I called it train A, the problem didn't have it called train A, so I can't reference it in the answer, using train A. Somewhere it gets tired and stops, and a second engine, let's call it train B, picks up and goes another 200 miles. So I'll try to make that one look a little bit longer than train A's distance. All right, I typed more words here because I knew we would be running out of time or had run out of time. If the second engine is going 5 miles an hour faster than the first engine, I said, eeny, meeny, miny, mo, let X be the speed or the average velocity of the slow engine. I could have let X be the average velocity of the faster engine. That would just change what I have here. If I let X be the velocity of the slower engine, then what's the velocity of the faster engine? Yeah, 5 miles an hour faster than slow is X plus 5. And then I'm trying to make a sentence. Does it make sense to say the velocity of one car plus the velocity of another car equals total velocity? That doesn't make any sense. It makes sense to say the distance gone by one plus the distance gone by the other is the total distance. No, I'm talking about distance. I'm not talking about velocity. My sentence is, it makes sense to say that the two distances together is the total distance, but we know the total distance is 340. It's time that we're given. So what formula has to be involved in this whole scenario? And most folks start with distance equals rate times time. And then when they realize that we're talking about time here, just divide both sides by rate, and time is the distance divided by the rate. Okay, I know something about the distance of each engine. I know something about the rate of each engine. So how could I get the time that the slow engine pulled? I know its distance is 140, and I know its rate is what? X, then what's its time?
Well, wouldn't it be over?
Yeah.
60?
Yeah. Its distance divided by rate is 140 over X. For the first engine. And then the faster engine, look, I'm going to use some subscripts here. I'm going to use D1 and R1 for the first train's distance and rate. So its time is 140 over X. For the second engine, I'm going to use D2 for its distance and R2 for its rate. So how long did it pull? Its distance is,
200 over X plus 5.
well, it's just its distance is 200 and its rate is X plus 5. So its time is 200 over X plus 5. And the equation, the sentence I've already written up here, the time the first one pulled plus the time the second one pulled is 9 hours. So what is that as an equation? I'm talking about changing this sentence. What do I put in place of time the slow engine pulled?
What about X?
Okay, stop right there. That's the first part, the time that the slow engine pulled, right here, the first engine pulled was 140 divided by X. Keep going, Augustus. What's the time that the fast engine pulled?
Plus 200 divided by X plus 5
And what's the total time they pulled?
equals. I have 3 for 9. but That's for velocity.
340 over 9.
That's.
That's distance divided by time, and you just want time. You don't want distance divided by time, you just want time. So what's the time the fast engine pulled? I mean, the total time pulled. Yeah. Yeah. This time the slow engine pulled is this. The time the fast engine pulled is this, and 9 is the total time. I had to clear out some fractions and it took me a little while to solve it. I came up with X equals 35. What is that 35? What about it?
It's.
Okay, so average velocity of slow train. And I'm never just gonna say average velocity is 35, because then I don't know if it's kilometers per hour, feet per second. What is it? Yeah, because our distance was in miles and our time was in hours, in P.8. And what is the average velocity of the fast train?
5 feet 4.
5 more than that is 40 miles per hour. It would take you a minute to check it. You'd have to say, the slow train's time was 140 divided by 35. The fast train's time was 200 divided by 40. See if adding those together give you 9. All right, last one. You have 30 hits at 120 times at bat. I assume you're playing baseball. You get your batting average by dividing your number of hits by your times at bat. If you only hit the ball 30 times and 120 times at bat, then your batting average would be you're hitting the ball 25% of the time, or your batting average is written as a decimal, 0.25. Got it? All right. How many consecutive hits must you get in order to improve your batting average to 0.28? So every time you hit the ball, you're bringing that average up a little bit. You're wondering how many times in a row do I have to hit the ball before my average would be up to 0.28? Let X be how many more hits I'd have to make. That's what I'm looking for, the number of additional consecutive hits. Then if I cover this up and say, if you hit the ball X more times, how many times total will you have hit the ball? Originally, you had hit it how many times? 30, and then you hit it X more times? 30 plus X is the total number of hits. What's your total number of times at bat? Well, your original times at bat was what? 120, and then you've hit it 30 more times. What's your number of bats now? I'm sorry, you've hit it X more times. Then 120 plus X will be your total times at bat. And your new batting average is always total hits out of total times at bat. And now we have something we can substitute in the place of both of those phrases. We can say total hits is the 30 plus X. total times at that is the 120 plus X. And your new average is 0.28. That's the equation you're solving. You come up with X equals 5. And that 5 is how many more times in a row you have to hit the ball in order to get that batting average up to 0.28. All right, you have 9 great examples in the book, 9 great examples on these 2 pages. So that's 18 examples of using words to set up equations to solve problems. And that's what I want you to practice. I want you to breathe and go slowly and use some words.